Hello everyone. In this video clip today, I'm going to go over one of the most important things in Calculus 1. We'll be talking about the biggest thing ever in Calc 1, which is called the derivative of a function. Okay, so this is covered in two sections, 2.7 and 2.8. We're going to go step by step to get to the derivative as a function. Okay, so let's start with something that we learned previously on 2.1 when I tried to introduce to you something called the rate of change, or the secant line and the tangent line. So say we have a graph, anything, okay, and I show you that we have, say, 2 points on the graph. The first point, let's call it point A. Second point is point B right here. This big A represents a point, this is big B for another point, and the point A is at A, f of A. The point B is at B and f of B. Alright? And then imagine that we are fixing point A. This line right here, by the way, we call it the secant line. Secant line. Okay? Imagine that we are rotating that secant line around the point A. In other words, the point B is tracing or moving along the curve and getting closer and closer, approaching the point A. Okay? B is getting closer to A. B is moving forward this way. Okay? So if B is right here, we have another secant line. B is right here, we have another secant line. Okay? And if B is very, very close to A, we're going to have something called the tangent line. And let me draw it with the red colored one. Okay? B is very close to A. We have this line right here, we call it the tangent line. Now that we have the limit to in hand, we can say it this way. We talk about the slope of the secant line. How do you find the slope of the secant line? Slope of secant line is m equal to f of b minus f of a over b minus a, right? Slope is change of y over change of f. So 2 points, b f b right here, a f a, change of b over change of f of f of b over f of a over change of b over a. You have this. All right. Now you want to calculate the slope of the tangent line. Remember what we talked about last time? The line that is touching the curve at just 1 point, because now that point B is very, very close to point A. You think of it like 1 point, okay? So for the tangent line, the slope of the tangent line is what? The limit of f of B minus f of A over B minus A when B approaches A. See? We talk about the tangent line, we talk about the slope tangent line. We find the slope is what? B getting close to A, right? Okay, point B getting close to point A. And this is the slope tangent line. Now that we have the limit, so we can probably write it this way. Are we good so far? And what is the slope of the tangent line at the point? This is exactly what we define as something called the derivative of the function at the point A. So in other words, the derivative of the function at the point x equal to A is no more than the slope of the tangent line at that specific point. And how do you find the slope of the tangent line at the point? You calculate the limit of f of b minus f of a over b minus a. Okay? To make it easier for you guys to see as a function right here, because now b is changing. In other words, b is variable. So instead of write b, I can change this to x then. We write it at x, and now it looks more like function. Think of b like x is the same thing, okay? Because we think of x as a variable more than the letter b as a variable. So think of x right here. X is any value of a function that's getting closer to a, and this is going to be f of x getting closer to f of a, okay? Then the ratio of changing of f of x minus f of a over x minus a, the changing of y over change of x. When x is very close to a, going to give you the slope of the secant line, but now the secant line is very, very close to the tangent line, and the limit going to give you the slope of the tangent line at the point. And we have another way of saying this, rate of change right here. Slope of the secant line is the average rate of change. I think we talked about this already. What's out of the entire interval from a to x right here, a to b right here, we have the slope of the secant line, which is called the average rate of change. But if x right here is very close to A, or previously I used B, right? Same thing. B is very close to A, we don't have the average rate of change anymore. We call it what? The instantaneous rate of change. The rate of change at that specific point, at that specific moment. Okay? Because in physics, usually that's the velocity. That's why the rate of change. Okay? So we have the instantaneous rate of change is the derivative, or the average rate of change is the slope of secant line. Okay? The instantaneous rate of change is the slope of tangent line. And that is the definition right here, pretty much for 2.7. And we covered this already, so now we're going to use a very formal name for it called the derivative. Now let's talk about notation. The derivative at the point A is denoted this way. F apostrophe with 2 means what? The derivative of the function f at the point x equal to 2. Or in other words, a is equal to 2 in here. Okay, so let me give you a specific example. Example. Say f of x equal to x squared. Okay? Let me show you the graph as well. The graph of this one is going to be like this. You know this is a parabola. Okay? So the origin right here, the vertex, x-axis right here, y-axis right here, when x equal to 1, 1 squared is 1, x equal to 2, 2 squared is 4. Okay? And can you find the slope of the tangent line at x equal to 2? Let me use green color to draw the tangent line. Tangent line 2 right here. This is tangent line. What is the slope of that tangent line at x equals 2? In other words, what is f prime of 2? Right? F prime of 2 means the slope of the tangent line at x equal to 2. We have nothing but the definition, so I gotta use a definition. So in here, our A value is 2. Okay, so we have what? F prime of 2. Why did I use green? Back to black. F prime of 2 is, by definition, limit of f of x minus f of 2 over x minus 2 when x is approaching 2. Okay? X is ending point approach 2. Then this is the slope of the secant line, but x getting close to 2, then secant line now becomes a tangent line. Gonna be the slope tangent line. So what is f of x? F of x is x squared. So this is the limit x squared. What is f of 2? It's 2 squared over x minus 2, and then x approaches 2. Now we have to use the technique that we learned how to calculate the limit from the previous section to calculate this. So this is limit x go to 2 of x squared minus 4 over x minus 2, right? 2 squared is 4. First of all, I tried to plug in 2. I got what? 2 squared is 4 minus 4 is 0. 0, and the 2 minus 2 is 0. I got 0 over 0, so it doesn't give me anything. I cannot say that the limit is equal to 0. That is incorrect. Somehow I try to simplify. I see it, x squared minus 4 is x minus 2 times x plus 2 and over x minus 2. And this is the limit when x goes to 2. Okay? And I can cancel out the 2 right here. It's equal to x plus 2 and x goes to 2. So what? 2 plus 2 is equal to 4. So the slope of that green line right here is m equal to 4. Another way, f prime of 2 is equal to 4. And we say that the derivative of the function at x equal to 2 is equal to 4. Okay? The same thing equivalently, say what the slope of the tangent line at x equal to 2. The slope of the tangent line to the curve, when x equal to 2, slope equal to 4. It means that the function tends to go up. Okay? With the slope 4. Try another one. What if I want to calculate the slope at x equal to -1? Another word, I want to calculate, I got f prime of 2 is equal to 4 already, right? What if I want to calculate f prime of -1? -1 is right here. And the tangent line is going to be like this. It's going down, right? So if we are correct on this, the slope will be a negative number because the line is going down. Slope f prime of -1. We're going to use a definition. This is the same definition. It's equal to limit of f of -1. I'm sorry, f of x minus f of -1. See, over x minus -1 when x approaches -1. Let me just write the definition up here because I erased it already. F prime of a is equal to the limit x approaches a fraction f of x minus f of a over x minus a. Okay? So in this case right here, a is equal to -1, f of x minus f of -1 over x minus -1. And plug in the function. This is limit x goes to -1. F of x is x squared. F of -1 is -1 squared over x plus 1. Because minus 1 is plus 1. This is limit x goes to -1. X squared minus 1. Right? -1 squared is still 1 and minus 1 over x plus 1. Same trick before. We factor out the top. We have limit x minus 1 times x plus 1 over x plus 1 when x goes to -1. -1. And of course we can cancel out the x plus 1 in here. So this is the limit x goes to -1 of x minus 1. Now you can plug in x equal to -1. So -1 minus 1 equal to -2. So really the green line this side was green. Has a slope of m equal to -2. Another word, f prime -1 equal to -2. Okay? So far, so good. And all the example I claims that if you want to use a definition, this is the typical work of showing the calculations. So let me write the answer up here. F prime of -1 is equal to -2. Try one more. Try the vertex. Vertex is right here. What is the tangent line of the vertex? It's going to be the horizontal line, you see. Actually, the x-axis right here. And what is the slope? The horizontal line should be 0, right? Really, f prime of 0. Was that equal to 0? We're going to calculate that. This, one more time, means what? I am looking for the slope of the tangent line when x is equal to 0. X equals 0 right here. And this is going to be my tangent line. Okay? It's going to be the x-axis. And I want to calculate so that. I know the answer because I know the graph of it. We want to double check. We want to make sure that we want to confirm that whatever we learn is correct. So use the same formula. F prime of 0 is equal to limit. Don't forget the limit. The limit f of x minus f of 0 over x minus 0 when x approaches 0. We plug things in. The limit f of x is x squared. F of 0 is 0 squared, well, which is 0. And x minus 0 is just x. And x go to 0. This is limit x squared over x. When x go to 0. You can cancel out the x on the top bottom. Limit x go to 0. And this is really equal to 0. So it really works. Okay. Now, we have a little problem. Say what? Anytime we're going to calculate a limit, we have to go back in here and we have to repeat the same calculation using the definition of derivative or the limit of the change in the y or change of x, and it takes a lot of work. Okay? Question, is there any way that we can expedite it? We can find the slope faster if they have a function called derivative function, and we plug in the value, we have the slope right away. And that's exactly what we're talking about in 2.8. So instead of plugging the value into the derivative function at the beginning and calculate the slope at that specific point, we don't do that. We find the derivative function in general first, and we plug in the value later. That will be more effective. This is what I mean. Okay. So we have the slope of the point right here, f prime of a is equal to limit f of x minus f of a over x minus a, right, when x approaches a. And let me draw the picture, redraw the picture, and I'll give you the general formula. You have this. This is my a right here, and this is x right here. This is f of a. This up here is, one right here is f of x. Okay? So, we're gonna introduce a new variable called h. H is different from x to a. So h is equal to x minus a. Is that okay? From here to here, how far is it? H. So how do we calculate this? I take x minus h. I'm sorry, x minus a is equal to h. So when x approaches a, it's the same thing of saying that what? X getting close to a is the same thing of saying what? That letter h right here is going to 0, right? X approaches a is the same thing as h approaches 0. Because with x getting closer to a, so x minus a is going to be closer and closer to 0. Okay? If h is equal to x minus a, you can think of x as what? H plus a, or a plus h. Let me write in the order of the book, right? So a plus h, a plus h. Adding a on both sides. So our definition right here, I can write this way. Define the derivative function f prime of x is equal to limit of f of a right here is x plus h. Oh, did I write it right? Yes. So this is f of x plus h minus f of x, right, all over h when h approaches 0. Are we good? So we think of a specific a right here is any x letter, and then now the h right here is like the b. Okay? The x right here is like the b. So we have this. This is our definition of the derivative function. Okay? Okay, so let's calculate that derivative function in general, see how it works for our example. So let's go back to our example. You guys can think of x plus h is like the b right here, right? Or the new x that we have. So b, f of b minus f of a over b minus a. And b minus h is the distance, going to be h. Okay. So, go back to the example. F of x is equal to x squared. Let me redraw the graph for you. Alright. This is x-axis, this is the y-axis. I'm going to use the definition of the derivative function. So I got, we write it in here, f prime of x is equal to limit h approaches 0, f of x plus h minus f of x over h. All right. Plug in our function. Our function is f of x equal to x squared. We know that f of x is equal to x squared. So f of x plus h is just x plus h squared, right? F in x squared out, x plus h in, x plus h squared out. Whatever the function, you follow the rules. So this is what? Limit h approaches 0 of x plus h squared minus f of x is x squared all over h. Now we have to simplify that numerator and combine the like terms, and hopefully it's going to get us something that's doable. Limit h go to 0. For this out, we have x squared plus 2hx plus h squared minus x squared over h. Make sure that you guys get it. X plus h squared is x plus h times x plus h, which is FOIL. X squared plus xh plus another xh and then plus h squared. So this is x squared plus 2xh plus h squared. This is what I have right here. We cancel out the x squared. We're going to factor out the h on top. Limit h approaches 0. Factor out the h. We got x plus h, 2x plus h over h. Okay, factor out the h. We have that. And then we're going to cancel out the h. We have limit when h approaches 0 of 2x plus h, and now plug in h equals 0. This is 2x plus 0, which is 2x. What is so good about this? It gives you something called the derivative function. And the derivative function say what? F prime of x is just equal to 2x if f of x is equal to x squared. Then f prime is 2x. Alright? Now we set up a plug-in value to the definition and calculate f prime at a point. We have the derivative function already. For x equal to 2, then f prime of 2 is 2 times 2, which is 4. X equal to negative 1. F prime of negative 1 is 2 times negative 1, which is negative 2. See, right here, derivative function. And then what? X equal to 0. F prime of 0 is 2 times 0, which is 0. You have the derivative values at a point. In other words, the slope of the tangent line at those specific point right away if you know the derivative function without going back 3 times and calculating the slope at the given point. Okay? So pretty much you guys got the main point for the two sections, 2.7 and 2.8. This is the main thing, derivative function. So before I start this video clip, I'm going to give you one more example of how to calculate the derivative function. Let me just look for another example. Let me just make up one. Something that we're going to use a technique of multiply by the conjugate, okay? We write a definition in here. F prime of x is limit h approaches 0 fraction f of x plus h minus f of x over h. Okay, that's our definition. That is the key for our lecture today. Okay, now example. Say f of x equal to square root of x. Find the derivative. F prime of x. What is that equal to? Okay. So we apply the equation right here. This is the limit. What is f of x plus h? F of x is this, so f of x plus h is square root of x plus h, right? So square root of x plus h minus f of x is square root of x all over h, with h approaches 0. Now, this limit have two radicals on the top, and one of the very useful techniques that I showed you last time from the previous section was to multiply by the conjugate to get rid of radical. So let's do it. Limit h approaches 0. The top, I'm going to multiply by, first of all, square root x plus h square root minus square root of x. Conjugate of this is going to be square root of x plus h plus square root of x. And then, since I multiply by conjugate, I got to multiply by the same quantity for the bottom. So square root of x plus h plus square root of x. Okay, and recall what we learned before. Let me write up here. A squared minus b squared was a minus b times a plus b. This is a minus b. This one going to be a plus b. And it's going to be a squared minus b squared in our formula. So it's going to be what? Square root of x plus h squared is going to be x plus h, right? And then subtract square root of x squared is going to be x, and everything over h times square root of x plus h plus square root of x. Okay? Let me write this way in my outer room. Make sure you guys see it. Oh, the top is going to be what? X plus h minus x is just h over h times square root of x plus h plus square root of x. I can cancel out the h. I will have limit 1 over square root of x plus h plus square root of x, when again h always go to 0. Okay? Now you're okay to plug in h equals 0. This is 1 over limit 1 over square root of x plus square root of x, and h equal to 0, and this is 1 over 2 square root of x. So we have the derivative function of square root of x. We write up here, f of x is equal to square root of x, then f prime of x is 1 over 2 square root of x on the bottom. Now, we have the derivative function. You are free to calculate the slope of the tangent line at any point. Say x equal to 1, then f prime of 1 is equal to 1 over 2 square root 1, which is 1/2. Okay? Say x equal to 4, then f prime of 4 is equal to 1 over 2 times square root of 4, which is 1 over 2 times 2, which is 1/4. Positive slope, right? What if x equal to 0? F prime of 0 is equal to 1 over 2 times square root of 0, which is 1 over 0, undefined. Why is that? Let me show you the graph and let's explain everything. The graph of f of x equal to square root of x looks like this. It is actually a half of a parabola, like this. Okay, including the point. This is y equal to, or f of x equal to square root of x. 1 is right here. 1 is right here. This is the tangent line. Slope is 1/2. 2, 3, 4 is right here. Slope is right here. Oh, I gotta draw it better. This is the line right here. And the slope of the tangent line is gonna look like this. Slope gonna be 1/4. When x equals 0, parabola this way, okay? So this is the tangent line. What kind of line is that? This is the vertical line, you see? What we learned before about vertical line, slope is infinity, or slope is undefined. And that matches the case right here. Okay? Hopefully via the 2 example, a couple examples actually, it helped you to get a better idea of what it means by the slope of the tangent line, which now we call the derivative of the function at a point. And we have the derivative function, alright? Instead of calculating the slope of the tangent line at a specific point, we're going to find the